Hello guys, welcome to H2O, the A to Z of chemistry. I am Dr. Ritu Johar, your educator for this course, General Organic Chemistry. Today we begin with lecture 7 from the course, but make sure you watch the previous ones before this one. In the last lecture, we began the discussion on the nomenclature of alkanes, wherein we learned how we are going to name the straight chain alkanes, which was very simple. Just we had the name of the alkane in accordance to the number of carbon atoms in the chain. The number of carbon atoms this gave us the word root, and behind that we simply put the suffix "ane" to get the name of the alkane, right? So now we will be moving further with the lecture and we will be discussing the nomenclature of the branch chain alkanes. So now before we can name the branch chain alkanes, you should have a clear understanding what are branch chain alkanes. We did this in the last lecture as well. So the alkanes, which are going to consist of small chain of carbon atoms attached at one or more carbon atoms of the parent chain, are going to be called as branch chain alkanes. For example, we have this over here, this molecule you can see over here, this carbon, it is attached to 3 more carbons. So when a carbon is attached to 3 or more than 3, that means it is going to be attached to 4 carbons as well. So this is going to be a branch chain alkane, right? So this is going to be the parent chain and this is going to be the branch that we have. Similarly, let us see one more example. This is going to be the parent chain, and then this is going to be one branch and this is going to be the second branch, because you can see over here this carbon is attached to 3 and this is also attached to 3 carbon atoms, right? Now what are these groups that are attached over here? The CH3, then CH2, CH3, if you just club it together it is going to be C2H5, and this is a CH3. So these are all what? These are alkyl groups, or you can say small chains of carbon atoms, and we have done a detailed discussion on the alkyl groups as well in the last lecture. Quickly revising, what are alkyl groups? They are going to be the groups where one hydrogen has been removed from a saturated alkane. And how are we going to name these alkyl groups? We will be taking the word root of the parent alkane minus the ane and adding a YL. I hope that is clear to you people. For example, we have methane, minus the H from that you will be getting CH3, and the name of the alkyl group is going to be meth plus YL. So we have ethane and ethyl, propane and propyl, butane and butyl. So all this we have already done in detail in the last lecture, so I will not be wasting actually more time over here. If you have not watched the previous lecture, please do watch that. It was a very important lecture where I told you about the various types of alkyl radicals as well, how we are going to name them as well. Very importantly, you should understand each and every concept that I taught you in the last lecture. All right. Now, one thing over here that you have to understand is we have the parent chain. We have to number the parent chain because we have to name it in such a way that we get the best possible name according to the IUPAC nomenclature. So here what you have to do is that you have to learn certain rules for the naming of the branch chain alkanes, which we will be learning one by one. So the first rule for naming the branch chain alkanes is going to be the longest chain rule. Now what do we mean by that? We have to identify the longest continuous carbon chain, which is called as the parent chain. So while in the last lecture also we were discussing about that we have to consider the longest chain, and according to that we will be giving the word root to the alkane, right? So first of all, let us learn how we are going to identify the longest continuous carbon chain. You see these two examples over here. This is one molecule, this is the other molecule, right? Although this incorrect numbering has already been written for you people, so you will be understanding that there is going to be something wrong. But what is that going to be wrong? Let us understand this. This is the molecule. I have numbered them from 1, 2, 3, 4. Is this correct? Is this the longest continuous chain? And similarly in this also, is this numbering from 1 to 6 a continuous chain? Is it the longest continuous chain? Well, no. Why are they not so? Let us understand this with the other numbering that we have over here. If you see the numbering in this molecule, the same molecule we have, I have just numbered it differently. So 1, 2, 3 and 4 and 5. Isn't this also a continuous chain? It is only that you can consider it that if you have one long chain and while playing with it, rather than keeping it straight, you just bent it somewhere and then made another bend. That is what we have over here. It is a continuous chain, one carbon joined to the other, and this is how a chain is. Right? So what has happened over here is now we have 5 carbons in this chain. We have 4 carbons in this chain. So which will be the longest? Obviously this one. So we have to number the carbon atoms in such a way that we get the longest continuous carbon chain. Right? Similarly in this also, this has 6 carbons, but if you just change your direction of thought and just put these numbers like this way, you will be getting 7 carbon chain. So this is how you will be choosing. You will just not be considering the straight chain. You will try to consider all possible countings so that you get the maximum length of the chain. Right? I hope this is clear. Let us do one more example over here. This is the one, right? So this is a 1 to 9 carbon chain, a big one, right? So you don't even think, well, it is seeming to be the longest one, but don't go by the seeming to be the longest one. Try all possibilities, right? And when you will be trying all possibilities, what you will be getting is this chain where there is 10 carbons in the chain. Right? So I just started numbering them 1, 2, 3, 4 to 10 rather than this. So here you can see these were 2 carbons, here they are 3 carbons. So this is going to definitely give us a longer chain, and that is how we are going to put this. Right? Good enough. Now we move on to the second rule. Now when we are going to number the carbon chain, first of all we have to identify the parent chain, which we have done in the last rule, right? Now what is going to happen? Let us see another thing. This is the same molecule that we were discussing in the previous slide. So this is how we had numbered, and there I had written that and this is a correct numbering, and now I have put it as an incorrect numbering. Why is it so? Well, let us understand this. I can put the numbers from 1 to 10 in this fashion, but I can also put the numbers from 1 to 10 in this fashion. Can't I start with 1, 2, 3, 4? I can do that. Now, why is this incorrect? Let us understand this as a rule over here. So what we will be doing is to locate the position of the carbon atoms at which the branching takes place due to the substitution of alkyl groups in place of the hydrogen atoms. So what we will be doing is we will just identify where we are having alkyl groups as the side chain. So here you are seeing the side chain at number 4, and here is one side chain at number 9. But now why is this incorrect? Let us understand this. What you have to do is you should number the chain in such a way that the branched carbon atoms, they get the lowest possible number. How is it going to be? Let us see this. So when we number the carbons from this position 1 to 10 this way, you will be getting a CH3 group at position 2 and the C2H5 at position 7. Right? Now this is a lower number. 2 and 4 is the comparison, right? So 2 and 4, and for the other one what you are having is 7 and 9. So both the groups you can see over here, they are getting a lower number, right? So we will be choosing the way of numbering in such way that the branched carbon atoms, they get the lowest possible numbers. Now what have we learned so far is that first we will be choosing the parent chain, which is going to consist of the maximum number of carbon atoms, right? And after we have chosen that, we have to number the parent chain in such a way that the alkyl groups, the substituents present on the parent chain, they get the lowest number possible. Now here we have two rules that you have to understand how we are going to give to the alkyl groups the lowest possible number. So the first rule is the first point of difference rule. Let us first of all understand the rule, and then we will be looking at one example of that, right? So this rule says that first of all, the number that indicates the position of the substituents or the side chain, call that as the locant. For example, in the previous slide, the molecule that you saw, there was a methyl group at position number 2 and an ethyl group at position number 7 in the correct structure, right? So these two positions of the carbons, that is position number 2 and position number 7, they are called as the locants, right? Now the next thing is that if the number of substituents is greater than 1, choose the name that gives the lower number at the first point of difference. Now what do we mean by the first point of difference? Let us understand this with the help of an example, right? So we have this molecule over here. When you are going to choose the parent chain, you will be seeing that this is going to be the parent chain with 8 carbon atoms. Now a 8 carbon alkane is going to be a oct plus ane, so this is going to be a octane. Now what we have to do is that we have to give the numbers to the substituents. When we are going to give the number to the substituents, well, you can number this chain from 1 to 8 in this fashion or 1 to 8 in the other fashion as well, right? So which one should be the way of numbering is what we have to understand. And what this rule is saying is that you have to give the lower number to the first point of difference. So what we will be doing, we will be writing it in the other way as well, right? When we write in the other way as well, this is going to be it. Now we have 5 methyl groups over here, which we will be writing as pentamethyl octane. Similarly over here also this will be a pentamethyl octane. Now we just write the numbers of these methyl groups that are present, or these locants that we will be writing. So in this case, the first locant is position number 2. Then we have 2 methyl groups at position number 3. So we have written a 3 and 3. And in the next one we have 2 methyl groups at position number 7. So the next locants are 7 and 7, right? In this case, what you will be having is there are 2 methyl groups at position number 2. So these are 2, 2, then 2 at 6 positions, so 6, 6 and 7. So according to this numbering, you will be having the name of the molecule or the compound as 23377 pentamethyl octane, whereas in this case it will be 22667 pentamethyl octane. Now which one is the correct? We have to see the lowest number at the first point of difference. Now first number, you see this is a 2, this is also a 2. There is a similar number. Move on to the next number. Here we have a 3, here we have a 2. So here is the first point of difference, and the first point of difference says that this is a lower number than this number. So we will be having which structure to be right? We will be having this structure to be right. Why? Because the number of locants over here is 2, 2, where the first point of difference has come, and this is a 2, 3. So 2, 2 is a smaller number than 2, 3, right? I hope this is clear how you have to number the parent chain that we get the lowest number at the first point of difference. Perfectly fine? Okay. Now, what you have to remember over here is the name is decided not on the basis of the sum of the locants. These are going to be examined by one. So the name you are going to give to this way, you are just going to number all the locants and you will be numbering it, okay? So you are not going to sum up the locants and write the name of the molecule. Now there is one more rule which also gives us the numbering of the parent chain, and the rule is the lowest sum rule. According to this rule, the parent carbon chain containing 2 or more substituents is numbered so that the sum of the locants is the lowest. What do we mean? In the previous example, we saw that we had given the numbers to the various substituents which we call as the locants. What this rule says is that just see those numbers, add them up and see the sum of them. Whichever is getting a lower number, that is going to be the name of the compound. Now what happens over here is that for the simple alkanes, both the first point of difference rule as well as the lowest sum rule, this will give us the same name. But when you see the complex structures or the highly branched alkanes, you will be seeing that there is a difference. The lowest sum rule will be choosing one name, and the first point of difference rule, this will be choosing another name. So what are you going to do over there? You will be in a fix. So what you have to remember is that you will be always choosing the first point of difference rule, even if it violates the lowest sum rule. Okay, so this is very important. Please do remember it. Why I have told you this rule is because this is mentioned at many places, and I want you to learn this very well, that you will be following the first point of difference rule only. Okay, now let us see an example which will help you understand this also. We have this molecule over here, and we have the other way naming also. So this we have named from 1 to 10, and this is from the other side 1 to 10. Now you write the numbers of the alkyl groups. So we have a methyl group at position number 2, 7 and 8. So what is going to be the name of this compound? According to this, the parent chain is a 10 carbon chain. So this is going to be a decane. We have 3 methyl groups, so it is going to be a trimethyl decane. And at position number 2, 7, 8, so this is 2, 7, 8 trimethyl decane. Right, on the other side, if you're going to write it, so it is going to be again a trimethyl decane, but the position of the substituents is going to be 3, 4 and 9. Right, now let us use the lowest sum rule. When you're going to add all these locants, you will be getting as 8 plus 5 is 15, 15 plus 2 is 17. So the sum of the locants is 17. Here when you're going to do the sum, you will be getting as 9 plus 4 is 13, 13 plus 3 is 60. So the lowest sum rule says that this naming should be correct. But the first point of difference rule says what? Just check the first number. Here we have a 2, here we have a 3. So which is the lowest number? This one. So which name should be correct? This one. So there is a difference, and where there is a difference, what are you going to choose? You are going to choose the first point of difference rule. So just for convention, what you do is always see the first point of difference rule. Do not just simply follow the lowest sum rule. Right? I hope this is clear. This is easier also, that you have named it in the two ways, and then you see the first number and the first number from both sides, and then you just do it quickly as well. I hope this is clear. This is please very important. Do understand this very well. Now another thing that you have to remember is that in some cases you will find that two alkyl groups are present at the same position from the opposite ends, right? So when you are going to number it from either way, there will be two alkyl groups and both are going to be present on the same numbers. Then what you will be doing? Then what you will be doing is that lowest number is given to that carbon atom which is attached to the alkyl group that first comes in the alphabetical listing. So if there are two groups, that is a ethyl group and a methyl group, at the same numbers, what you will be doing is you will be numbering that carbon number a lower number which is having the ethyl group, because alphabetically E comes before M. So the order is going to be E, M and P according to the alphabetical order. Let us understand this again with the help of an example. Without examples, it is not going to be clear. So you have this molecule, the parent chain is having 6 carbons, so this is going to be a hexane, right? Now when this is going to be a hexane, you can number it from this carbon, so you will be getting ethyl group at position number 3 and a methyl group at position number 4. Just reverse the order of the parent chain, you will be getting this numbering. Here you are getting a 3 to the methyl group and 4 to the ethyl group. So essentially it is 3 and 4 position here, and similarly a 3 and 4 position here. So there is going to be no first point of difference, both are the same numbering. So what we have learnt is that we will be giving a lower number to the ethyl group over here, because E comes before M according to the alphabetical order. So this naming would be correct, where we have a 3 ethyl 4 methyl hexane rather than a 4 ethyl 3 methyl hexane. Okay, I hope this is clear. Now we move on to the next rule, which is for the numerical prefixes, and I think this will be clear to you people with the previous examples as well, that for substituents which are occurring more than once, numerical prefixes like di for 2, tri for 3, they are added before the name of the group. So this we have done with the examples in the prior ones also. This you can understand with one more example. So we are going to number the parent chain, and when we are going to number the parent chain, this is going to have 6 carbons, so this is a hexane. You number it from either way, you will be getting 3 4 position to the methyl groups, so we can put the numbering in any way, right? Now these both are methyl groups, so it is going to be a 3 4 and dimethyl, so we have added a prefix di because we were having 2 methyl groups. So I hope this is clear. The next we have is that the name of the alkyl groups attached as a branch, they are prefixed to the name of the parent chain, and the position of the substituents is indicated by the appropriate number. And this also, again with the previous examples, I think these things are now very clear to you. If the different alkyl groups are present, they will be listed in the alphabetical order. Now let us see this also with an example. So we are having this as the parent chain. So this is one which we have already seen previously also. So this is a decane, right? And a decane with a methyl group at position number 2 and a ethyl group at position number 7, right? Now this is how we are going to name them, but one thing that you will be remembering is that we have a methyl group at 2. So what you can think is that you write 2 methyl and 7 ethyl, but you will not be doing that. First you will be writing 7 ethyl and then 2 methyl, because you will be arranging the alkyl groups in the alphabetical order. Okay, so I think this is clear. You will not be writing this as 2 methyl earlier and 7 methyl decane. You will be writing as 7 ethyl, 2 methyl according to the alphabetical order of the alkyl groups. The next we have is rule number 4, which says number for each group. What does this mean? When there are two identical substituents at one position, numbers are supplied for each one of them. Let us see the example. So this is the same example that we have seen earlier also, where this was a 8 carbon parent chain. So we have octane. There are 5 methyl groups. So we have to put a prefix before the methyl, that is going to be penta. So this becomes pentamethyl octane, right? And now what this rule says that you have to give the number to each substituent. So at position number 2 we have 2 methyl groups, at position 6 we have 2 methyl groups, at position 7 we have 1 methyl group. So for all of them you have to give a number. It is not that if there are 2 methyl groups present on the same carbon, you will be just omitting for one of them. You will not be writing this as a 2,6,7 pentamethyl octane. You have to write it as a 2,2,6,6,7, a number for each substituent. I hope this is clear. Now the next rule. So the next rule we have is for naming the complex alkyl substituents. Now what do I mean over here? Let us understand, and this is an important one also because you've not seen it in the previous examples. So this is the molecule that we have, and now let us start it from the beginning only. So we will be first of all choosing what? We will be choosing the parent chain, and for that we have to see the longest carbon chain. Now you are seeing already the numbers have been given, but you will not be given that in the examination. You will have to do that yourself. So you will be first of all, I think, starting with this one over here, because this is the first one to strike, and when you are going to count them, these are also 8 in number. Okay, so from 1 to 8 this is also there, and from 1 to 8 this is also there. Now why have I chosen this as the parent chain and not this one? Let us understand this, because this is not in the rules over here. So let me tell you that as well. So when you are going to choose the parent chain, see a more substituted parent chain. Okay, so for example in this one, if you start numbering from here 1 2 3 4 5 6 7, or from this side also, you will be having one substituent over here and one substituent at position over here, right? So this would be, if we start from this carbon, it will be position number 3 and 4, where we will be having two substituents. But when you look at this chain over here from 1 to 8 in this way, you have a substituent at position number 2, 3, and then at 4 as well, this one. So we are having 3 substituents and here we are having 2 substituents, right? So we will be choosing that chain where there are more number of substituents also. Okay, one thing this is clear. Now we have chosen this chain, and when we are going to choose this chain, you can see that we will be getting the lowest number when we are going to the substituents when we start numbering from this side. So this side we have number 2, and if we start from this side, it will come at position number 1, 2, 3, 4 and 5, right? So the point of first difference is going to be at this place at position number 4, and here we have position number 2. So you can clearly choose which is going to be the numbering way that we have. Now we come up to the naming of this. Okay, so this is a 8 chain compound, so this is going to be what? This is going to be a octane. Now when this is a octane, you have to write first the carbon atom at position number 2 there is a methyl group, and then at a 3 position there is a methyl group. So this becomes 2,3 dimethyl. Now what is there at position number 4? We have again a branched substituent. So this is not a straight chain substituent, this is itself, it has a branch, because why? This carbon, it is linked to 3 carbons. So isn't this a branched substituent in itself? Now how do we write the name of this substituent? So what we have done is we will be again numbering this substituent also according to the same rules. We will be starting this as number 1, just adjacent to the one of the parent chain. You will be starting that as the number, right? So this is going to be 1 dash, this will be 2 dash, and this will be 3 dash. If you choose this one, it will be 1 dash and 2 dash, and so therefore you will be choosing the longest one. So this will be 1 dash, 2 dash and 3 dash. Now 3 dash means there are 3 carbons, so this is going to be what alkyl group? It is going to be a propyl group, right? And now when this is a propyl group, there is one methyl group at position number 1 dash. So we have written as 1 dash methyl propyl, and this you will be writing in the bracket. Okay, so I hope you understand how we are going to name the complex alkyl substituents. You will be naming them just as the alkyl group in accordance with the nomenclature, and then you will be putting the whole thing in the bracket. So this becomes 2,3 dimethyl 4 1 dash methyl propyl octane. I hope this is clear perfectly well. Good enough. So the next rule we have is a one word name. Now let us understand what do we mean over here. The name of the compound is written as one word. Okay, the name contains numbers separated from the name of the substituents by hyphens. So you have been seeing them in the names earlier. Now I am just putting these things that you have to write the name of the compound as one word. The name, if it is consisting of any numbers, they have to be separated from the names by hyphens. The numbers, they are separated from each other by commas. So 1 1 or 2 2, 3 3 dimethyl. So this has to, the numbers, they have to be separated by commas. So in the example, again I have come back to the pentamethyl octane. So there are how many numbers over here? We have 5 numbers. So these 5 numbers, they have to be separated from each other by commas. Then the name of the compound, this is one line together, there are no spaces between, and between the numbers and the name we have put a hyphen. So I hope this is clear how we are going to write the name. Step by step we have learned everything in this. So we have to choose the parent chain. Parent chain has to be the longest carbon chain. So it is in what direction? It is upward direction making a long chain, or in a downward direction there are bends. So you have to choose the best parent chain, which has to be the longest carbon chain. Then you have to number the chain. When you are going to number the chain, you have to see which is the substituents, they should get the lowest numbers. How are they going to get the lowest numbers? We will be seeing the first point of difference rule. When we see the first point of difference rule, that is going to be the best name that we will be giving. Then we will be naming them. If there are going to be similar alkyl groups they are present, you will be using prefixes like di, tri, so on, and then you will be numbering each of the substituent. When three in the numbers, you are going to put commas. Between the name There are going to be no gaps, and the numbers and the name, they will be separated by the hyphen, right? I hope this is clear. So that would be all for this lecture. In the next lecture, we would start on with the nomenclature of the unsaturated hydrocarbons, that is the alkenes and the alkynes. I hope you liked this lecture. If you did, please do click on the like link, and also do subscribe to the channel and click on the bell icon so that you get a notification the moment we put up a new lecture for you. Do practice a lot many questions on nomenclature. This is really very important for you people, right? And if you have any doubts, most welcome, put that in the comment section. You can well, you may not be able to type the nomenclature structures, so you can even click photographs. You can mail us those photographs and we will be answering you back. Even you can join us on the Facebook page of the channel, which is by the same name, H2O Chemistry. Even there you can put up your doubts as well. We would be really glad to help you people. Thank you and have a nice day. God bless you.